All right, today we're starting with parent functions. Now, I want to make something very clear to you before we even start talking about the specific parent functions. Do you know what a parent function is? It's like where all the other functions come from, right? The parent, does that make sense? But I want to make something very clear. There's no such thing as a mother function. Okay, I know that's fun to say sometimes because it's really close to another word. Okay, but I don't want you walking around in the hall talking about mother functions. Okay, because you're going to get called to the office for cursing in the hall, and then you're going to say, well, Miss Kingston taught it to me, and then I'm going to get called to the office, and I don't want that to happen. Okay, so parent functions, not mother functions or father functions, just parent functions. Fair? All right. So parent functions, okay? Have you ever heard of parent functions before?
Yes.
Good. A lot of the stuff we're going to talk about in the next couple days or even weeks is just a reminder of what you did in Algebra 1. But for some of you, it's been 2 years, and some of you, it's been 3 years since you've been in Algebra 1, so we got to remember some stuff together, okay? So let's start with this first one. What kind of a parent function is this? Well, excuse me, what kind of a function is this? Do you know what it's called? It's a linear function, right? Linear. That's okay. We'll go with it anyways. Okay? Linear. L-I-N-E-A-R. Well, make a guess. What kind of shape do you think that makes when you graph it? A line, right? Because it's a linear function, it's going to make a line. Well, let's go about proving that. Okay? Let's choose some x values here. What kind of x values do you think we should choose? 1. Okay. What else? 2. 3, 6, okay, 8, 10. You think we ought to choose 10?
Yes.
That's probably, why would that be on the edge of what we want to choose? That's as far as the graph goes, right? So we have to make wise choices when we choose our x values. I don't mind choosing 10, that's fine. But I want you to think about other values we might choose. -1. What else? -2, -3, -6, and there's one more that nobody said that almost everybody always chooses. 0. Yeah, 0. Okay. So some people are confused by this because there's an x and a y, and when they look up here, this is written in function notation, which means there's no y's. Are you guys okay with that? What's another way to write this equation? Y equals x. Y equals x. Okay? So, what values did we choose? We chose the x's, right? What are those values called? What's another word for those values? Input. Yeah, excellent. Input. So what are we going to get from the y's? The output. Now, is that the only name? No, we have independent variable, dependent variable, we have x, we have y, we have domain, we have range, we have all sorts of words that we're going to talk about in the next couple days. Okay? So, if my equation is really y equals x, and I know x is 1, what's y? 1. If I know x is 2, what's y? X is 3. X is 6. 6. 8. 8. 10. Good. What about 0? 0. Okay. Now, plot those points on your graph, please. 1, 1. 2, 2. 3, 3. 6. Oops. 6. Ignore that. 8. 8. 10, 10. -1, -1, -2, -2, 3, -3, -6, and 0. It's okay. It's the tardy bell for May lunch. You're okay. Did you draw a line through your points? Why not? Because I didn't? I think you're thinking of the word continuous. Is this data continuous or is it discrete? How is it given to you? An equation, right? So what if I said x is 0.5? Can you find a y value? 0.5, isn't it? What if I said x is 0.25? What's y? 0.25, right? So is it continuous or is it discrete? The table is discrete, I agree with you, but where did we get the table? From the equation, right? Because of that, it is continuous and we can connect them. Please don't connect them just the ones we have. Please connect them like this to the edge of the graph because we're allowed to, because it's continuous. And what else did I add on the end of each line, or each end? An arrow. What does that imply? That it keeps going. It continues, right? Not necessarily that it's continuous, but that it's continuing. Okay? What do you know about domain? It's the x's, right? Okay, so let me write that real quick to remind us. X values. What are the x values allowed to be in this function? When we're talking about x's, which direction are we talking about? Yeah, left to right. A lot of you are doing hand signs like horizontal lines, right? That's good. Okay? We're talking about left to right. How far to the left does this go? All the way? How far to the right does it go? All the way. What's a good math way to say that? Close. I mean, that's one way to say it. We'll talk about that in a minute, but what is it? How about this? What does that mean? All real numbers. Okay? All real x values. All real numbers. What about the range? Oh, for the record, there's another way we're going to talk about it. I might as well go ahead and talk about it now so we have it documented on our video. Okay? There's another way we're going to talk about range, and we will talk about the name of this way later on. I just want to start talking about it right now. Fair? Okay. We're going to say negative infinity to positive infinity. If you can't draw infinity signs, turn your paper sideways and draw an 8. Nobody's going to judge your infinity signs to your face. Okay? What about the range? If domain is x values, what's range? Y values. And if domain is left to right, what's range? Can I argue with you for a second? Why do you think we talk about domain being left to right? What specific order are we talking about? Negative to positive. We say left to right. So then how should we talk about range? Down to up. That's exactly right. Okay? Now, that's not some sort of correct mathematical way to talk about it. Down to up. That's like a regular person way to talk about it. But if we're talking about negative to positive in domain, let's talk about negative to positive in range as well. Left to right and down to up. It'll help us keep our thinking clearer. Okay? So, how far down does it go? All the way? How far up does it go? Okay, so what can we say? All real numbers. And what's the other way we can say it? Negative infinity and positive infinity. Now, you need to know something funny about this, okay? There's people that do math all day, every day. That's what they do for their job. And they have fights about things. This is one of the things they fight about. Is there such a thing as negative infinity? No. Why did I write it then if there's no such thing? It's a notation that we've adopted. Okay? It's a notation we've adopted to talk about what direction. Left or down, right? I'm reminding myself I'm talking about to the left. It goes all the way to the left, so I'm telling myself negative infinity. Positive, it goes all the way to the right, so I'm saying positive infinity. I want you guys to make sure you know it's just infinity. The negative and positive kind of thing is a notation that we have adopted to help us remember what we're talking about. You okay with that? Okay. Special things we're going to talk about later, so don't worry about that for right now. Okay? What about number 2? It's squared, so what's it called? Do you remember what kind of function is it? Quadratic. Yes, close. Quadratic. It's a quadratic. Okay, how about this? How about this one? What kind of shape does a quadratic make when you graph it? You're showing me with your hands. Do you remember what it's called? A parabola. Very good. Okay, the quadratic is the kind of function it is. The parabola is what it makes when you graph it. Okay, so what kind of x's are we going to choose? 1, 2, 4. You know what? I wouldn't choose 6 this time. Do you know why? I wouldn't even really choose 4, but I wrote it down so we could talk about it. Why would I not choose 4 or 6? What happens when you square 4? Try again. Try again. It goes to 16. And what do you know about the graph? And it goes to 10, right? So I could still choose it. I still went ahead and wrote it down in the list for you. But do you see why I wouldn't choose 4 or 6? You can choose them. We can't graph them. Okay? So what else might we choose? -1. I heard a 3 also. What else do you want to choose? -2. What else? 0. How about -3 as well? Okay, so let's fill out the chart. Now, I know some of you are really freaking out right now. I can see it in your eyes because these are not in order. We'll work on getting the next one in order. How about that? Yeah. Okay, all right. So let's jump around a little bit right here. Not the song, not the song. I just mean jump around the numbers right here, okay? So what's 1 squared? 1. What's 2 squared? 4. What's 4 squared? Remember we talked about that a minute ago. That's why we probably wouldn't choose it if we had a choice next time because it's not something we can graph. What about -1 squared? What's -1 times -1? It's 1. What about 3? 9. What about -2? 4. 0? 0. What about -3? 9. Okay, so go ahead and plot those points on your graph over here. 1, 1, 2, 4. I can't graph that one. -1, 1, 3, 9, -2, 4, 0, 0, -3, 9. Can we connect these? Why? They're still continuous because they came from a function, right? An equation was given to us and we were able to get all those. So if I had 1.5, I could square 1.5 and still get a value for it, right? That made sense? Now, there's going to be some time we talk about discrete stuff, okay? It's just not right now, okay? So I can connect these, so I'm going to go ahead and connect them. Remember, we're not playing dot to dot. I'm not going zhin, zhin, zhin. This is a function, and it's kind of a curved kind of thing, okay? Like that. So, are we ready for domain? Yes? Okay. What's the domain? X values. So what kind of X values are we allowed to have in this problem? We're talking about left to right, remember? How far to the left does it go and how far to the right? All real numbers, right? Some people said, well, it stops right here at 9. Well, does it? Well, we drew an arrow, right? And some people said, well, it's just going up. Well, I agree with the fact that it's going up, but every time it goes up, doesn't it also go over? Yeah? Okay, so our domain is all real numbers. Negative to positive. So what about the range? Well, why is it not all real numbers? It doesn't go all the way down. How far down does it go? To 0. It starts at 0. How far does it go up? all the way, right? So our y value is going to be greater than or equal to 0. Now we got to talk about how to write it this way. Starts at 0 and goes where? Infinity. But look at this. Why did I draw a bracket instead of a parenthesis? Yeah, it's part. 0 is part of our answer, isn't it? If 0 was not part of our answer, we would have a parenthesis there. But having a bracket there means we know it starts at 0. Like you can say, you know where the end is. So I don't have a bracket over here. Do you know where the end of infinity is? Me neither. So we can't imply that we know where the end of infinity is by putting a bracket here. Anytime we have a parenthesis here, anytime we have an infinity here, it will be a parenthesis. Okay? It'll just depend on if we know that that's part of the answer or not, whether we can put a bracket there or a parenthesis. Okay? But again, we'll have some more work on that, some more time on that in the next couple days, and you'll get to understand that better. Okay? Just a general introduction. We're talking about all the parent functions this week, and then we're going to take each one by one, and study it the rest of the year. Okay? What about number 3? What do you think that's called? No, but that's a good guess. Hunter? This x is cube, right? So what kind of function is it? It's a cubic. Yeah, it's a cubic. Very close. Okay, it's a cubic. So what kind of numbers do you think we're going to choose for our x values here? Do you think we have to be more careful or less careful? More careful, right? Okay, so let's try to think of it in like numerical order. Where do we want to start? Is there numbers less than 0? Okay, maybe we should start somewhere else then. What about -3? Okay, we're going to put it, because I want to give value to what your answers are. But let's think about this. -3 times -3 times -3. -27, right? -27. Is that something we can graph? No, I put it anyways because I wanted to have the conversation. Fair? Okay, so what about, what should we choose next for x? -2. What is -2 times -2 times -2? -8, that's right. What do you think we should choose next? -1, and then next 0, and then 1, and then 2, and then should we choose 3? No. We know it's possible, right? We just probably don't want to put it on our table because we can't graph it. Okay? So what is -1 cubed? -1. What's 0 cubed? 0. 1 cubed? And 2 cubed. Try again. 8. Okay, here's the deal. You're going to mess up like that all year. I'm going to mess up like that all year. When he said the wrong answer, did I immediately make fun of him? I'm treating him with respect, so I'm not making fun of him. Because when you mess up, he's not going to make fun of you either. I won't allow it. Okay? I'm not saying I'm not going to make fun of you. Okay? Some of you definitely need making fun of. Okay? But I'm not going to make fun of your math skills. I'll make that deal with you right now. Okay? All right. So let's graph what we can. Graph what we can. So -2, -8, -1, -1, zeros, 1, 1, and then 2, 8. Again, guys, we are not playing dot to dot here. This needs to be a nice curved function. So make sure you take the time to do that when you're graphing it in. Woo! That was poor. That was very poor. Okay, do better. Do better on yours. It's always harder when you're doing it in front of someone. You know that, right? You can set the ball 50 times in practice, but when you have an audience, you're going to carry or whatever that thing is, like this, right? Or something like that. All right, so what's the domain? How far left does it... Uh-oh. Hold on. Okay. How far left does it go? All the way? How far right does it go? All the way. So what's the domain? Absolutely. I know you said it before. I'm just taking you through the thought process. The other way to write it, negative infinity to positive infinity. Is it? Are you positive?
Yes.
Good. Range is all real numbers too. Because we say how far down does it go? All the way. How far up does it go? All the way. Okay? Negative to positive. Okay so far? Look at number 4. What's this one called? Now, if you say square root function to me, I'm going to know exactly what it's called. Right? Exactly what you're talking about. Square. But that's not the actual correct mathematical name. But I want you to have square root there because, again, if you know it's a square root and you call it square root function, I'm going to know what you're talking about. But here's what it's actually called. Radical. This symbol that's over the x is a radical. That's what it's called. So it's a radical function. So, more careful or less careful when picking our x's? Like way more, right? Way more. Because what kind of values do we want to choose for x? I want to choose something that I know that'll fit the graph, that I know the square root of, right? That's exactly right. Okay? That's your bell. Okay? So here's what I want you to do. I want you to finish the table and graph, domain and range for 4, 5, and 6. Okay? Finish the table, the graph, domain and range for 4, 5, and 6. We will talk about those tomorrow, and we will continue with some of the special things and so on. Okay? Have a great day.